In 3D experiences, it is common to have large textures and complex models. Through the network, it can lead to long loading times. To avoid to display to your users a blank screen and give them a bad impression about your website or even make them leave, we can use a loading screen. My opinion about that is that when it can be avoided, it should be avoided. Don't just use a loading screen for every project. Optimizing models and texture should be the first choice, unless it's a design decision, of course. But sometimes you don't have the choice. Your project relies on the 3D and the models are the most important, so you need to display a loading screen. That's what we will learn together. This is the starter project that we have. We have 4 different characters in 4 different files, and we have the text with a special font. If we reload, we can see a blank screen for just few milliseconds. It's because I'm running the code locally. But we can go to the developer tools, go to the network tab and fake a bad network by going here and fast 3G. I also have the cache disabled, and let's reload it. Now the blank screen is much longer. You can see it's loading the models. To avoid displaying a blank screen for our users for too long, we can use the suspense component. It's a wrapper component we can put over the loading resources. That comes with a fallback property, which says while what is inside is loading, we can render what is in the fallback. Let's use a cube loader component in the fallback. We need to import suspense. It's a component from React and not from React Refiber or any 3D related stuff. And let's create our cube loader. We'll return a mesh with a box geometry and a mesh normal material. Let's remove the throttling because it is way too slow. Reload. And now, while it's loading, it displays the cube, then it renders our scene. How does it work? Suspense is waiting for data to load. It listens to promises inside it to detect if there are something loading. Inside our experience, you can see I don't have promises or anything loading. But if we look at our code to our models, we are using useGLTF, which we know is an abstraction of useLoader from React Refiber. And useLoader is using promises to load the resources it requires. That's why inside our app, Suspense is waiting for the promise to be resolved. But an issue you can face is if a component inside your experience is not required at the very beginning. Let's try to do it to display what is going to happen. We will add a king visible state. So we will render our king conditionally. Let's create that state here. King visible, set king visible. We'll be using useState. Don't forget to import it. Then in a useEffect, we will display it after 1 second. So, oopsie, set king visible to true after a set timeout of 1000 milliseconds, so 1 second. Let's reload. We now have the cube, then there is no king and it appears after. Let's do it again with the network tab open. We can see everything is loaded and then 1 second after king.gltf is loaded. So it's still related to your network speed. To avoid that and to tell our suspense component to wait for it also before rendering the whole experience, we can go inside the king, copy the useGLTF. On the bottom of the component, so just after, we can use useGLTF.preload and set the path to the model. We can save, and because our king is imported inside the experience here, it will call that function here, the preload function, which will, like the other components, load it at the very beginning. Now let's try to reload. You have all the data loaded, and when the king appears, we don't have new network request because it was done before here. Maybe you have noticed in the previous lesson that we already had useGLTF.preload. It is because by default, when we use gltf JSX, below the file, so after the component, we have the preload automatically done. It is very important to know what it does and why we use it, because in some cases you might want to avoid using it. For example, let's say our king, we want to display it 1 minute later only if the user do a specific action. Maybe we can avoid loading it at the very beginning and delay its loading and not impact the whole loading process. Now, instead of displaying that cube loader, let's try to render a loading screen. We'll name it loading screen. Of course, you can declare it in a separate file, but we will do it for the moment. To get data about the resources loaded in real time, we will use the useProgress hook. It's coming from Dry Library, and it returns many information about what is going on. We have active, which as its name states, it means is it loading something or not. Different errors that could occur loading specific resources, maybe a path not found. Item, the current item which is loading. Loaded, the number of items that have been loaded so far. Progress, a number between 0 and 1 to get the progression of the loading. So you multiply it by 100 and you have a percentage. And total, the detected number of items to load. Let's keep it simple and only use the progress. Then we will return our interface inside a div. Again, like in the other lesson of this course, we will be using vanilla CSS, but choose your favorite framework or a way of styling components. Class name is equal to loading screen. Inside, we will render a subdiv that will act as a container, so we can center it easily. And then we will add a title, 3D Web Agency. Class name is equal to loading screen title and a text element with P stating the loading. We'll be using parse int of progress multiplied by 100. So we have the percentage value and %sign. Let's save and we can remove the cube loader here because we won't use it anymore and remove it from the fallback component here. Now, if we reload, we have the loading and the percentage. Well, I made a mistake. It's already a percentage, so we can remove the multiply by 100. We need to remove it here. And my bad, progress is a value between 0 and 100. Okay, now we have 100. Let's style a bit our loading screen. We go to index.css. We create our loading screen rule. We start by using position fixed, so it will never move. We set the top to 0 and left to 0. And we set a padding of 4, so there will always be a little bit of space, even on mobile. We set the width to the full width of the screen, and same for the height. Then we put the z-index to 1, so it's above the canvas. We set display to grid, so we can use place item center to center our content in the middle of the screen. Then we define the background color and use background image to create a gradient. On top of the file, let's import Interfont from Google Fonts. Now in the body, let's apply that font. Font family, Inter or sans serif. Now we can make our title bigger inside our screen, which is __ title. We set the font size to something bigger, the font weight to make it bold. We transform the text to uppercase, so we don't have to manually write uppercase letter. We set the color and set margin 0, so the default one applied on H1 is disabled. But we have an issue with the padding applied. It's not correctly set. We need to set box sizing to border box so it's applied correctly. We can also center the text inside. Now it's perfectly centered and we can see our loading here that is changing. Let's use a progress bar instead. Go back to app.jsx, remove here the progress. We'll create a new div. Let's name it progress __ container. Inside we'll have another div. It will be our progress _ bar. And we'll need to add some styling to it. It's width. That will be the progress with the %sign for CSS. Let's jump to the CSS to style our progress bar. We have progress __ container and progress __ bar. We make it full width based on the parent size. We set the height to something we like. We change the background color, make it relative because the bar inside will be absolute based on our container. Overflow hidden, and we add some border radius. Now let's jump to the progress bar. By default, we are starting from 0. So we set the width to 0. Then the one we defined here in the style inline will be applied. We set the height to be the full height of the container here. We choose a background color. And we set a transition over the width to smoothen the transition between different values. Now we can see our progress bar that is filling it entirely. Now let's make our loading screen disappear when resources are loaded. In our loading screen component, let's get if it is active, so is it loading something or not. Then we will conditionally display a class name, wrap with brackets. Let's add backquote so we can add the variables inside. So if active, we do nothing. We just want loading screen like now. And if it's not active, we want to say loading screen with the modifier hidden. Let's add the styling for loading screen hidden. We can go just below loading screen. We'll add hidden modifier and let's declare what it does. Let's add an animation that we will name fade out that will last 0.5 seconds and that will go forwards. We create our animation without keyframes. We name it fade out. At the beginning, it's 0%. The opacity will be set to 1. And at 100%, which is the end of our animation, we want the opacity to be to 0. Let's reload. We have the progression and it smoothly fade out. Because we set visibility to hidden, we don't have an issue with the loading screen interfering with the orbit controls below. Now you know how loading resources work with React Refiber. It is a very important topic to give your users the best experience. Dry Library also offers a loader component. It's a nice component to use maybe for development purpose, but I don't think it is production ready because you can customize it as much as you want. But now you know how to create yours.